All right, guys, good morning, good morning. I think we'll go ahead and get started. Today I kind of wanted to wrap up shell method for volumes of solids of revolution. Reminder, once again, tomorrow we have our last content quiz for class on volumes of solids, disk, washer, shell methods. And then next Thursday, week from tomorrow, we have our end of course assessment. If either of those two dates, if either of those two dates don't work for you, you're unable to make the call at those times, please let me know. I need to make other arrangements in order for you guys to get your work wrapped up and get you your credit and your grade for the year. So if that doesn't work, please communicate that with me. We got into shell method on Monday, actually. I showed you a link that looked like this. Shell method, we're going to make a solid revolution by rotating this blue rectangle around some axis of revolution, and thereby creating a cylinder, as you can see on the right. If I find the surface area of that cylinder and all of the different size cylinders that make up the solid using a definite integral, I'll in essence have the volume of that solid. All of those nested cylinders that make up the figure, by using a definite integral to accumulate and combine all the different surface areas of those cylinders, will create the volume of that particular solid. Okay, some notes here from class on Monday. The shell method is going to be based off of the formula for the volume of a cylinder. The shell method to find the volume is based off of the surface area from a cylinder. And the surface area of a cylinder is 2 pi times the radius times the height. In these notes up here, they use P of X and P of Y for the radius. Just notation, no big difference there. The radius is the distance from the axis of revolution to the figure that you're rotating. The height is the overall height of the region you're rotating. When I rotate this region around some axis of revolution, it creates a nested cylinder, as you can see down below. Using a definite integral, we can combine and accumulate all of the different surface areas to create the volume. What I wanted to look at today is rotating a region around an arbitrary line that's neither the x nor y axis to find the volume for our region. So in this example, we're going to find the volume of a solid generated by revolving the region bounded by the graphs of y equal x cubed plus x plus 1, x equals 1, y equals 1, about the line x equals 2. Notice that we're rotating around a line that's neither the x nor y axis. Okay, and then I'm going to go ahead and also graph the line x equals 2, but I'll make this a dotted line because that would be our axis of rotation. So it would appear that we are rotating kind of this region bounded here in the middle of our figure about the vertical line in purple x equals 2 to the right. So I'm going to go ahead and make a quick sketch. Okay, so here is our region. We're going to rotate around the line x equals 2. We have the functions x equals 1, y equal 1, and y equals x cubed plus x plus 1. Now, it didn't say to use the shell method, but why would the shell method be preferable for this question?
Because it's a vertical axis of rotation.
Absolutely. It's a vertical axis of rotation. And when I rotate my region, if I outline that here, maybe in red, the radius is some distance along the x-axis. Oops, that's the wrong radius because now we are over here on the right side. The radius is some distance along the x-axis. So like you said, yep, the volume is going to be in terms of a definite integral with x. Okay. What would the radius and height be? I want the radius. We have some value x over here on this side. I know the total distance from left to right is 2. So what would the radius be on the right?
Would it be 1?
Say again.
1.
Not 1, because remember the radius can change based off of where I place that rectangle. I want the radius here. The total distance is 2. This value would be x. So what would this distance be? Well, if this is 2, this is x, then this would be 2 minus x. We had x here. We had 2 here. So what's left over for our radius is the difference of 2 and x, 2 minus x. How about the height? This whole distance from top to bottom is x cubed plus x plus 1. But I only want to go down to y equals 1. I do not want to include the entire height. Or the entire x cubed plus x plus 1 for my height.
Would it just be x cubed plus x?
Where'd the other 1 go?
Well, wouldn't you be subtracting 1 since you don't want that extra height?
Yep. So if I do plus 1 and then minus 1, because I don't want that extra distance down below, those just cancel out, leaving me x cubed plus x as my height. So the volume is going to be given as 2 pi times the definite integral from 0 to 1 of the radius times the height. So quantity 2 minus x times x cubed plus x dx. Let me pause there for a minute before we start evaluating that. Are there any questions on getting this set up?
How did you get your bounds for your integral?
We are rotating a region bounded on the x-axis for values between 0 and 1. This region from left to right only goes between 0 and 1 on the x-axis, even though I'm rotating around x equals 2.
Okay.
Does that make sense?
Yeah.
Okay. So if I carry this over to the next page, we have 2 pi from 0 to 1 of 2 minus x times x cubed plus x dx. Let's start simplifying. Looks like 2x cubed plus 2x minus x to the fourth minus x squared dx. Nothing to combine, so let's go ahead and start finding the antiderivative. Looks like, what is that? 1/2 x to the fourth plus x squared minus 1/5 x to the fifth minus 1/3 x cubed to evaluate between 0 and 1. So when I plug in 1 and 0, it's not necessary to plug in 0, so let's just plug in 1. So 2 pi times 1/2 plus 1 minus 1/5 minus 1/3. Let's see, what would a good common denominator be? 30? So 15/30 plus 30/30 minus 6/30 minus 10/30. See, that's going to be 45 minus 16 to make 29/30. Multiply those together and it's going to be 29 pi over 15. Any problems there, ladies and gents? Let's just double check here on Desmos. Put 2 out in front times the integral from 0 to 1 of quantity, the radius 2 minus x times the height x cubed plus x dx. Gives me that rational number, which is 29/15. Put the pi in for 29 pi over 15. Looks like we're good there. Good example of using shell method around an arbitrary horizontal or vertical line. Big difference is how you attack this radius. So rather than just x, now it's 2 minus x because we're rotating around the line x equals 2 to the right. That's kind of the big key component there. All right, last example is from the practice problems on Schoology. And this is actually what's going to be mostly what your quiz looks like. I'm going to give you one region. I'm going to ask you to rotate around several different horizontal and vertical lines. And you can use either the disk washer or shell method, disk washer or shell method to get your answer. Now, obviously, you could use either one, but I think there's probably one that's more preferable than the others, whether it's a horizontal or vertical axis of revolution. Is this something that you guys want to try on your own, or do you want to work through this together? Be happy to get you started. Or if you want to try this on your own, that's fine too.
I prefer together.
Try it together? Okay. If you guys want to work ahead and kind of check back with us to make sure that your answers are right, you're certainly welcome to do that too. We're looking at y equal x cubed, y equals 0, and x equals 2 around 3 different lines, the x-axis, y-axis, and the line x equals 4. So let's see what we got. Y equals x cubed, y equals 0, x equals 2. Now we're looking at several different lines, but here's the same region we're using for all of them. Kind of this curved triangle almost here in the middle. So for the x-axis in part A, we have a horizontal axis of revolution. Would it be best to use disk or washer or shell? Right away, I know it's not going to be washer because there is no gap between the axis of revolution and the region we're rotating.
Would you use disk?
I would use disk. When I use disk, we're going to create a cylinder and find the volume of that cylinder. The depth of the cylinder, the height of the cylinder, is going to be some length along the x-axis. So using disk method, I can keep my definite integral in terms of x. So some reminder here, some kind of from last week. The volume using the disk method is pi times the definite integral from a to b of the radius in terms of x, because we're doing a horizontal axis of revolution, the radius in terms of x squared dx. What would that radius be?
Is it x minus 2?
Nope, not quite.
I took a guess.
Is it y equals x cubed?
It would be x cubed. Any point on this curve can be found by taking the x value and plugging it into your equation, y equal x cubed. So the height or radius in this case would be found using x cubed for x values between 0 and 2. So pi times the definite integral from 0 to 2 of x cubed squared dx. Any thoughts there? Okay, x cubed squared would be x to the 6th. The antiderivative of x to the 6th would be x to the 7th over 7. I love when 0 is the lower bound because it kind of eliminates half the work. All I need to do is plug in 2. 2 to the 7th is 128. So it looks like 128 pi divided by 7, rotating around the x-axis. Yep, 128 divided by 7. Don't forget, because we're using disk washer, we're not putting a 2 out in front. We're using pi r squared volume rather than 2 pi r h for shell method. We're rotating the volume rather than the surface area. Problems with first part? Okay, let me kind of build this back. Now we're going to rotate around the y-axis. Disk washer or shell? Which would be preferable here?
Shell.
Shell method. Why shell method?
Because you're going around the y-axis.
So a vertical axis revolution.
Mhm.
If you wanted to not use shell method, you'd have to use washer because there would be a gap between your region and axis of rotation. But if you were going to use washer, you'd have to use a dy definite integral. Your two radii would be 2. And if I solve y equal x cubed for x in terms of y, it'd be the cube root of y. Your two radiuses would be 2 and the cube root of y. You'd get the same answer. It might just be more algebraic work. I'm going to take the path of least resistance. Let's use shell. So the volume is 2 pi times the definite integral from a to b of r of x times h of x dx. Let me redraw the same rectangle again. I need the radius and height. What would each of those two equations be?
Is the radius 2 minus x?
That's going to come next. Well, it's going to be 4 minus x in part C, but the radius is just some distance over here on the left. If I was rotating around the line over here, then it would be like 4 minus x, 5 minus x, but this is just some x value varying between 0 and 2 for the definite integral for our radius. So I believe the radius should just be x. Does that sound right? Does that make sense? Since our axis of rotation is on the left and not the right, we can leave our radius as x. How about the height? I think the height would again just be,
Would it be x cubed?
yeah, x cubed again for sure. Nice. So h of x equals x cubed. Our volume is 2 pi times the definite integral from 0 to 2 of the radius x times the height x cubed dx. Any other questions on how I'm getting that set up from there? Okay, 2 pi times the definite integral from 0 to 2 of x to the 4th dx. The antiderivative of x to the 4th would be 1/5 x to the 5th let's see, 2 to the 5th, is that 32? So 2 pi times 32 fifths. Multiply that by 2, and I see 64 pi over 5 for our final volume. So as a rational value, yep, 64 fifths for a final volume, 64 pi over 5. Okay, now we're going to do the same thing, but we're going to rotate around the line x equals 4. So while I get this kind of redrawn again, think about what I want to use, the disk washer method or the shell method. What are your thoughts?
You could do washer, or you could do shell.
If I choose to use washer, would I have to use a y or x definite integral?
Would it be y?
It would be y. You'd have a much more complicated definite integral. So since I'd like to keep everything as simplified as possible, I think since we're doing another vertical axis of revolution, let's use shell method one more time. So since we're using shell and we're rotating around the line x equals 4 to the right, the radius is now this distance. What would that be as an equation? It's no longer just x. This was x over here. What's to the right for our new radius in part C?
Four minus x.
Perfect, yeah, 4 minus x. If the total length from left to right is 4, and this was x earlier, then wouldn't this region to the right be given as 4 minus x? That makes sense. The height is and has always been x cubed. So for the line x equals 4 as our axis of rotation, we have 2 pi times the definite integral from 0 to 2 of our radius 4 minus x times our height x cubed dx. Looks like 4x cubed minus x to the fourth once I simplify. And then when I find the antiderivative, x to the fourth minus 1/5 x to the fifth between 0 and 2. Don't forget the 2 pi out in front to carry through. 2 to the fourth is 16. Two to the fifth is 32. So 32 fifths. If I find a common denominator, I think that's going to be 80 fifths for 16. $80 minus 32 is 48. So 2 pi times 48 fifths. 48 times 2, 96 pi over 5. So we had 2 times the definite integral from 0 to 2 of 4 minus x times x to the third dx. 96 pi over 5. Any questions there? Well, again, that'll be what your quiz mostly looks like. I'll probably have a handful of lines for the same region for you to rotate around. You can use either disk, washer, or shell method. The choice is yours. Just as long as you show your work, should be no problem.
Could we practice the washer method?
Yeah. Can I pull up some practice problems?
What's the best way to know like when you should use the shell versus when you should use the washer method?
The shell versus disk, which one's best? I would say it depends on what your axis of revolution is. For a vertical axis of revolution, use shell. For a horizontal axis of revolution, use disk.
Okay, perfect.
see if I can find a good one here. We try 9C, Patrick. That'd be a good quick example of what a washer method would look like.
Sounds good.
Okay, so 2x squared, y equals 0, and x equals 2. I think we're rotating around the line y equals 8. This is 9C again. And then we're rotating around the line y equals 8. So I'll make that dotted so that we can distinguish it. And there's our region. We have that same kind of curved right triangle here. And our axis of rotation is up on top at y equal 8. So why would it be preferable to use the washer method here?
Is it because there's like a gap between like?
Yeah, there's a gap, so we have to use washer. Why wouldn't we want to use shell?
Because it's a horizontal line and not a vertical line.
Perfect. So now there are two discernible radiuses for us to account for. The big radius and the small radius. The big radius is the total distance from top to bottom. Everything. That's capital R. Lowercase r is the gap, what we're going to subtract off, what I don't want to include. So what would those two values be? Well, the big radius would just be 8, wouldn't it?
Yeah, and then would the little radius be 8 minus 2x squared?
You got it. This equation gives us 2x squared. I want the part above it, so that would be 8 minus 2x squared. Patrick, does that look okay since this was your question?
Yep.
Okay. All right, so the washer method is going to be pi times the definite integral from a to b of big radius squared minus little radius squared dx. So we have pi times the definite integral from 0 to 2 of 8 squared minus 8 minus 2x squared squared dx. That's going to be 8 minus 2x times 8 minus 2x. I always have to write that out just so I know what I'm expanding and multiplying. So pi times the definite integral from 0 to 2 of 64 minus quantities 64 minus 16x twice plus 4x squared. So the 64s are eliminated. This looks like positive 32x minus 4x squared. Let's see, antiderivative of 32x should be 16x squared. Minus 4/3 x cubed. To evaluate between 0 and 2. Let's see, 16 times 4 would be 64. Minus 4/3 times 8 would be 32/3. Don't need to plug in the 0. 3 is the common denominator, so 64 times 3 gives me 192 thirds minus 32 thirds. So is that 160 thirds? 160 pi over 3. Where did I make my mistake here? I think I know where it was at. This would be minus 4x to the 4th. So that would be 5, 5, and 5. 2 to the 5th is 32. So 128 fifths. The common denominator is 5. So 64 times 5 is 320. $320 minus 128 is 192. Pi over 5. Make sure that's right here. $192 pi over 5 should be right. Why aren't we getting the right answer here? Oh, I bet I know. It's minus 32x squared here. So that would be 32 thirds x to the third. Gosh darn it. So that would be 32 times 8 to make 256 thirds. Common denominator would be 15. So 1280 here. And 384/15 for the next part. 1280 minus 384 is 896 pi over 15. That's going to be the right answer now. Didn't expand that right, even though I wrote it out. So I guess that's why you check. Okay. Sorry, Patrick, that was my fault. Didn't get that algebraically expanded correctly.
No, it's fine.
When I wrote that right there. That was my bad. But the setup process makes sense, though, right? That's the important part for doing a definite integral and getting it set up correctly.
Yeah, makes sense.
Okay. Yeah, washer is really where you have a gap. Because we didn't want to include the full top to bottom, we need to subtract off what we don't want to include, the inner smaller radius, lowercase r. Was there anything else, guys? I know we are quickly running out of time. Okay, once again, let's do 10 o'clock for a quiz tomorrow. And then next week, we'll spend some time doing some review for the end of course assessment. I've got the study guide and answer key linked for that on our distance learning calendar, as well as the Schoology page. If there's any questions over S23, volumes of solids of revolution, or your end of course assessment, please let me know. Otherwise, have a good rest of your morning, guys. We'll see you next time.
Have a good one.
Yep, see you guys.